Okay, now we're going to move on to the more exciting part of this particular session. It's Chapter 8, Hypothesis Testing. I'm going to do 8 and then go backwards and into 7 a little bit. This is going to require a little more cognitive thought. If you have your textbooks, page 235 will be the example we work with here, and it's all about blueberries and cognitive functioning. So they do a Wisconsin card sort task, and it turns out that when you measure people's cognitive ability, the average score, let's see, the average score for a group of older adults on this Wisconsin card sort task is 80. The standard deviation is 20. And the whole idea here is, will blueberries help cognitive functioning? The blueberry hypothesis. So the idea is, and the data I would like you to use is, if we know mu is 80 and sigma is 20 with our sample in this particular situation, please turn to page 241, and they actually give some more data here, somewhere on here. Let's see, it looks like on 241 on the very top, let's say people eat blueberries for 6 months, and after they eat the blueberries for 6 months, the new mean, M we'll put. Sometimes I use M, this case I use X bar, it means the same thing. X bar is 92. We had 25 people taking these blueberry supplements, and the standard deviation is still 20 here. So the question that we want to ask is, do the blueberries help? That's the big question. So we would have our hypothesis here, and the hypothesis would be, do blueberries help with cognitive functioning here? So that's kind of the big question we want to ask, and we'd have to do a computation here to figure this out. So the z-score formula seems like a good place to start. And the old z-score formula that we learned was, take the score they get, the x score, subtract it from the mean, and then put it over sigma. But we can't use that formula anymore, because now we're not just dealing with one person, are we? We're dealing with 25 people. So the new formula has to be a little bit different at this point in time. So look at the new formula here. Look at the numerator here. The new formula, the z-score formula, instead of just x minus mu, it's now x bar minus mu. And once again, mu and the symbol u are the same thing there. X bar minus mu. So that is the numerator, and if you think about, what do we want to happen to the numerator here? We hope that the blueberries really work, and we hope the numerator is really large. In this case, would it be pretty simple to compute the numerator here? Yeah, the x bar is 92, the mean was 80, so the numerator is 12. The numerator is called the treatment effect. That's when you have the blueberries, how much does that really help you? We always hope the treatment effect is large. We want the treatment effect to be a large situation if we find statistical significance. So the numerator is that. The denominator, and the denominator is a pain in the patella. The denominator used to just be sigma, but now it's sigma over the square root of n. And the reason it's the square root of n is because now we have to take into account the sample size. Do you know, when you run a study with a sample, do you want a large sample or do you want a small sample? Most people say you want a large sample. The denominator is actually called the standard error of the mean. And anything that has the word error in it, how do we want the error to be? We want it to be small. And the way we get our error to be small is if we have a large sample size. So we want the numerator, the treatment effect, to be large for the z-score. We want the denominator, the standard error of the mean, to be small in this equation. So that is the idea behind it. I don't know. We'll go back to doing the math a little bit later on this, but this is the new formula. It's a new formula because now we're not just dealing with one person like we were in chapter 5 and 6. Now we're dealing with, we have 25 people and we got a mean for those 25, so we want to see if the blueberries did work. So now it's using means and sample size. So hopefully that makes sense. I'm going to go into a little tangent next and then take us back to where we need to go. Thanks, everyone.